So thanks for joining me tonight. My name is Andrew Scuddy from SMUG. I'm talking about external references. If any of you have been to my presentations before, or if you've had the unfortunate event to have met me somewhere else, you realize I'm not that professional and I joke a lot and it's all kind of really informal. So if you have a question, raise your hand, glad to answer it. If there's heckling in the audience, I accept the challenge, no problem. It'll be fun. That's the obligatory slide about me. We'll pretend you all quick read that. Here's my universal rules about CAD. Really one fundamental one that leads to the second one. Everything changes and everything breaks. Not when, not if, not sometimes, not if radar designs it, just it breaks. With that in mind, a good CAD designer thinks about what's likely to change, what's likely to break, what's likely to happen, and builds their model around that to limit your liabilities. When it breaks, how can we recover with the least amount of effort and correct and resolve it? That type of thought process. And the important thing is not all breaks are bad. There's legitimate times when your model errors and you're like, I'm really thankful that that errored. Because if it didn't error, I wouldn't have caught it, and then I would have gone on and something would have been worse yet. So just because you get red in the feature tree doesn't mean that you could have done your model better. It could be a very intentional, this is red because something happened. External references. You do not use external references in a product environment. So if I was designing tables and I had to design the caster and that caster goes on 50 different tables, having external references in that caster is a very bad thing. Because the one table that I put that caster on would work just fine. But then the second table I put that caster on, that caster is going to reference the first table, and you're going to have this massive spider web of references. So if you're a product designer, you do not use external references. FOG is basically a product design company. Our parts are shared throughout the machines. If you're a project designer, like probably most of you in this room, then you can use external references with less risk, but there's still considerable risk. External references are allowed when working with complex geometry. I mean, who thinks part nesting when you hear external references first, right? Like you're given an automotive part and you're like, yeah, I can't make a nest unless I have an external reference. That's just hand in hand. There's no way around that. And then, or if it's exclusively inside of a project. So this is a custom desk for a customer that I'm never going to design before, never going to design again, make one, ship it off. Probably what most of you guys do. Use external references, not as bad. And then those of you who are thinking that this is going to be a woohoo, external references are awesome presentation, I'm still fundamentally against them. And you should avoid them when possible. Like if there's legitimacy to it, fine. But if you don't need to, don't use them. Some quick examples would be mirrored parts. If I have a part that I need a left and right hand of, I'd mirror inside of that part. Mirror bodies over, delete bodies, or mirror bodies with merge result and cut away the other half. A couple reasons. One, you don't have an external reference, which is bad. And if I ever come across the left or the right hand of that mirror, if I right-click and open the file, and I open, if it was external reference mirrored, I just open up an external reference and I can't do anything with it. If it's a mirrored configured, and I right-click and open that mirrored file, then it might be the wrong configuration, but I can just switch the configuration, make my edits, go back into my model, everything is great. Complex parts that interact. I have a couple examples here. This will not just be PowerPoint. I actually quite despise PowerPoint, so I'm gritting my teeth in getting through these slides. But complex parts that interact. I've got a couple of really good examples coming up, but if you have 3 or 4 parts that are very complex, that all interact together, that have to geometrically fit in a particular way, using external references can often be to your detriment. So you can do it all in one part file, configure it out, do multiple bodies, run body deletes, configure it out into configurations, and segment them out. You can still have your own drawings. You can still have your own part numbers. There's no limitation on the end of it. It's just how you manage your references. And then virtual parts. This is mostly more purchased commodities. But external references are a risk. They're bad. They're performance laden, all that. But external references still apply to a purchase component. When you guys all download an SMC cylinder or a PhD slide or something, how many part files do you get with an SMC cylinder?
Minimum of 2.
Minimum of 2, but usually like 12 or 14, right? So how many risk points do you have then if you download an S&C cylinder, you have 12 or 14 files in one assembly? You have 12 or 14 risks. Files can move, the names can be deleted. Every time you copy, move, you pack and go or give it to the customer, there's 12 or 14 files you have to move everywhere all of the time. And if any one of those aren't there, stuff blows up. So virtual parts, if you're not familiar with virtual parts, I will cover them in more depth, but virtual parts eliminates that risk. So that's pretty awesome. All right, when or not. So external references, and again, I'll mention this is being recorded. I tend to power through my stuff because I like to get to the SOLIDWORKS side. So if I'm speed talking, it's because I am, if you thought that. External references are necessary, but at least recognize design intent and make sure you're doing it with the least amount of risk. For example, if there's an orthographic bolt hole pattern, so how many of you like take a Destaco clamp, put it in your design, edit the part, drop 4 holes in that Destaco clamp to hold it in place with external references, right? Who does that? Okay, when that Destaco clamp changes, because it always does, how many errors do you have? 4. If instead, and I'll show this as well, but if instead you drop that Destaco clamp in and you kitty-cornered, or catty-cornered, depends on how southern you are, 2 external references, opened up that part file, and then drew 2 horizontal and 2 vertical lines and dropped in the other 2 holes, when that Destaco clamp changes, how many errors do you have? 2. The design intent can be embraced, and that's assuming it's orthographic and not at an angle, and there's a bunch of other stuff, right? But when the design intent is embraced, you can limit your risk, and when something changes, the next guy, because again, you have to assume it changes, somebody else is working on it, you're sick or something. It's less risk and less problem for them to resolve. So for high, and I have an example of this too, but for very high complex or high risk items, whereas like if you're doing an offset surfacing of a part fixture, if you lost that external reference or it broke or a file changed or something like that, you know, how much work do you lose if you spent, well, I didn't give you the answer, right? But if you spent however many hours doing a surface offset, knitting it all up, cleaning it all up, cutting it all out, and doing your nest, right? If that broke, that's a lot of time. So it is a viable option to have a dedicated assembly just to manage those references. And I have an example of that. And then be sure of your assembly structure. Use external references as late as possible. When you drop the Destaco clamp in your design, do you immediately put holes in it? No, we use distance mates and we say that's kind of where I want it, and then you adjust your mates. Then after the design review, after your sign off, after everything, then you go around and you plaster it full of holes. So do it last. Avoid restructuring your assembly, right? Before you start heavily using references, don't be taking parts and dragging and dropping them up among your assembly tree, dropping them in different assemblies, because that breaks things. And renaming, SOLIDWORKS has come a long way with supporting rename, but it's still a risk and it still messes stuff up. And the biggest rule that I see violated the most, that causes the most performance degradation among everything, is not using external references at the lowest level possible. It's very, very key. Who understands what I mean when I say that? See 1, 2, 3 hands, a handshake, a hand wave. I got a diagram. Oh, there's my diagram. I thought it was one more slide. So, best possible scenario. I've got part 1, it's my Destaco clamp. I got part 7, that's my plate I got to bolt it to. They're both in the subassembly 4. I open up subassembly 4, I edit part 7, and I drop in holes referencing part 1. Right? That's the shortest possible external reference loop you can possibly have. Again, we want to avoid external references where practical. And you know, there should only be 2 here, not 4. But that's still the best thing. Yes, Rick? Did you raise your hand? No, sorry. Corner of my eye, something glared. So not ideal, right? Is to go 1 level higher. This is a subassembly, so I could open up that subassembly. But what I often see when I'm at customers or doing consulting work, somebody has a big assembly open and they just, whatever assembly, whatever level, they click edit part, they start dropping in external references. And you're making this loop, which is not ideal, right? The top one there, avoid at all costs. Notice that the green, the orange, and the red, all those colors are hard to see on here, but the green, the orange, and the red all come from part 1 and point to part 7. The only difference is what assemblies they loop through. Right? That's what I mean by the lowest assembly possible. You need to make sure your reference loops through the lowest assembly process possible. Now if we come over and look at, oh, I gotta find it now. Purple. So I need part 10 to reference part 11. So I have to go up the tree of part 10 till I find an assembly that has part 11 as a child. Right? So part 10 here, I kind of go up. I find assembly 3. Assembly 3 goes down to part 11. I can't go any lower than that because otherwise those two parts aren't on my screen at the same time. So this purple loop here is a necessary evil. But if you could restructure something, or if there's something better you could do to limit, to get that level lower, the better it's going to be. But I recognize that happens, right? That's a necessary evil. And then this is the rename or the move scenario, where part 9 is referencing part 3, and then part 3 happens to move up out of assembly 5 into assembly 1. So this is your first scenario, and then number 2 gets moved, and number 3, now you have a broken reference. So once you start using external references, this is how SOLIDWORKS is mapping it. Part 9 says, when I'm in assembly 5 will tell me where part 3 is, and then we can figure out what we're supposed to do. And when part 3 disappears, part 9 gets really confused. And we don't want confused part 9s in our models. Any questions so far? Any comments?
Could we get a giant printout of this for our office?
So as I mentioned, this is being recorded. All of the content that I'm allowed to share, which won't be all of it, I'll share my PowerPoints. The SOLIDWORKS files are, I probably won't be able to share. But the recording of this and at bare minimum, the presentation will be uploaded to YouTube after this meeting. So yeah, and I have business cards somewhere. I'll give you whatever. No, that's a Logan's 25% off thing. I don't have any business cards. I have some in my bag. Yeah, I can get you whatever you want, no problem. All right, external references, why? Because, and I'm going to stand up because I like standing up. Because it's better, it's faster when they're helpful. And as long as you understand how they work, build them in a robust way, and be consistent, you'll probably have a pretty good time with them. If you don't follow those examples, it might be a little rough. The cost. Every relationship, except insert part, needs an assembly. And that's kind of the diagram we're talking about here. Your assemblies are the central key to all your external references. So if you don't manage that well, you're going to have a really hard time. And then the risks. Depending on your design, editing and make can change a bunch of stuff. So when I think about the mistakes I made as a designer, yeah, I've made them. Rarely was it the actual design itself, right? Like typically the 3D CAD I put on screen worked quite well. The mistakes I made was managing my data, doing second grade math, figuring out bills of material, managing my revisions, changing something and not remembering it, not communicating it to purchasing, not getting what I wanted ordered on time, not managing it through the shop floor. Right? Those are the fundamental mistakes I've made as a designer, more than the design itself. Anyone going to agree with me on that?
Your lie.
Okay, so I had one head and one heckle, so whatever. One head nod. So the risks are, and I've done this myself, right? The risks are, oh, I need to move that distacle clamp. But I forgot that the distacle clamp was center line mated with something else, which had a bunch of holes in a different plate. And that plate moved, and then I changed one mate and 10 parts in my SOLIDWORKS changed. Well, if you don't have revision management control, and you don't have PDM, it's just everything is read-only, you hit save all, and woohoo, I'm done. Well, they already started making that plate on the shop floor. I thought I just moved the distacle clamp. I thought I just edited one part, and I actually edited 3. So I revised one part, brought one drawing to the shop floor. That one drawing got updated, and now nothing matches when the assemble puts it together. Now the problem is when I load it up in SOLIDWORKS, it all matches. So you just grab your measure tool and you start measuring the differences to try to figure it all out. PDM helps a little bit, but it also hurts because now you have to have ownership, you have to manage it, you have to rev it, you have to check it back into the vault, but at least it's maintained in control. And I kind of just summarized that. The big problem is when I open up the assembly, right, all the parts update. But if manufacturing opens up one part in isolation, it'll be wrong. So those of you that have ever been burned by that know what I'm talking about. Those of you that haven't been burned by it, just remember that I said that. And then when you get burned by it, come watch this presentation later.
It'll also burn you with e-drawings too. Somebody on the shop floor opens an assembly of e-drawings that maybe
Oh,
primary
yep.
assembly,
Yep.
it still looks wrong.
That's why at every opportunity I try to burn e-drawings. All right, so I think we're going into tips and tricks now. Yeah, so let's jump into SolidWorks here a minute and actually start looking at some of this. Oh, I thought I had SolidWorks running. I'll start closing out of my email here and stuff so we don't get notified on stuff. Okay, so my first example. This is a FOG part I lifted out of their design library. So this is a pretty complex sheet metal part. It's got lots of angles, lots of radiuses, lots of it's not an easy part. And everything has to match. This is all continuously seam welded, cleaned up. And this is a pretty difficult part to do if you had to not have external references, right? If you had to design one part at a time, put in an assembly, and tweak all the dimensions till it fit. Especially because everything is angled and it's just weird. So when I started working on this particular project, the engineer at the time was using an assembly and external references and tying all this together. But it was kind of slow, and that particular method had its issues. The approach that I took, I redesigned this as a demonstration. The approach that I took is I designed the entire thing as a multi-bodied sheet metal part. It's all the same gauge, it's all the same thickness, it's all the same K factor, bend radius, except for that. It's all the same everything. But I was able to accomplish it in 3 distinct bodies. So here's the front, or that's the back technically, back cover, sorry. And no, this was also a different exercise as well. But particularly with sheet metal design, I'm straying from external references a little bit. You want to bend the longest side possible, weld the shortest side possible. If you can figure that out in sheet metal, like who's ever welded, I don't know, this is like 16 gauge sheet metal or something, 12 gauge, 14 gauge. Who's ever welded like 3 feet of 14 gauge sheet metal? Okay, and if you welded 3 feet and you notice that there's like a 3-inch bend here, right in the corner of the box, don't you kind of wish they would have bent the 3 feet and you could have welded the 3 inches? So in the world of sheet metal, if you can remember that, bend the long, weld the short, you'll be a hero. So here's the front lip. That's the long rolled bend and a couple bends there. Then here's the main pan with a 2-inch bend here. But the point is here, we're trying to bend everything, but it's all constructed in a single 3D file, which allows me, and there's not a ton of features here, but allows me to make cuts. And I can make cuts across multiple parts, across multiple bodies. It's all normal too. It's all native sheet metal. And then when I'm done, all I have to do is run 3 body deletes. I get 3 different configurations. Each configuration has its own flat pattern. I can make 3 drawings pointing at the 3 configurations. I get 3 part numbers. I can send 3 dedicated files to the laser house and get them lasered. Everything works. It's fundamentally no different than 3 part files in an assembly. It's just how it's geometrically designed, constructed, and how the files are referenced and managed. Any questions on that? Okay. I thought that was going to be more exciting. I guess not.
It's a very beautiful part.
Thank you. It's not my design. I copied somebody's design just to demonstrate it could be done this way. So I can't take credit for the geometric design of it. But that's and I just use sheet metal as an example, but it's any multi-body parts. I have a different multi-body part example here as well. So here's a fixture I designed for a customer a while ago. I wasn't allowed to show my customer's part. So we just see the surfaces and the nests. So nobody's supposed to be able to recognize what this is. But it's an edge wrap machine. And there is these PhD slides here that are supposed to wait for it. So there's 5 PhD slides here with contoured jaws. So they would load the part, and these slides would slide into the part, and this whole plenum goes up and down. So they slide over the part, and then the whole plenum would come down and tuck the fabric around the edge of the part with contact glue, and then they would be able to take the part out. And then these Destaco clamps here hold down. They come down and ride on all these windows of the part to make sure that they could hold the edges out to the side of the nest and hold it down appropriately so that the slides can come over and edge wrap. So pretty simple concept. Who's ever designed an edge wrap machine knows they're a ton of fun, and even more fun to tune and tweak. So maybe I like them. But anyway, the first thing I want to demonstrate here is in this particular design, at what level do I have this plate and this nest and these jaws all external referencing the customer part? Right? They're all fundamentally at different levels of the assembly here. This has to go up and down, these have to go in and out, the nest has to be stationary. There's no singular subassembly or no easy way in the top level design or anything to say, this is where I'm going to construct all my external references. Right? I can go back to my thing here. Right? We want these loops to be as small and short and concise as possible. So who has an idea? Or if this was your project, what would you do? Yes, sir?
Couldn't you just put that part in the part?
You could. That'd be a lot of geometry, but that is possible, yeah.
Couldn't you export the surfaces that you need to an STL or a step file or an IGES file?
Yep.
And then import that in so that you avoid connection to the original part?
It's not the connection to the original part that I'm trying to avoid. It's managing my references through an assembly. Sir, in the back.
Could you make a separate assembly that you put only the part and the parts that make contact with it in and reference it there?
You're a freaking genius. Yeah, so that's kind of what I did here. I made an assembly, just call it the fixture assembly. I put in the customer part only, and then I made the nest, the jaws. Notice I clicked on that one part and all the jaws highlighted. That's the key to my next part here. And then the top plate here. So this assembly itself has no reference, no use, no bearing whatsoever on the machine design that I showed you. It's just a token throwaway assembly to manage that green loop. And when I want to work on it, it's the smallest, least amount of geometry possible to look at, to reference, to external reference, to manage, to work inside of. I don't even have to have, I don't even have to have this assembly loaded on in my computer's memory to work with all my surfacing and all the complex features that I need to do to make that part. I manage my references, minimize my risk. I can jack up my assembly 6 ways to Sunday. This will never fail. In the statistical aspects of risk management, it'll never fail. So if we look at this jaw design here, I was very tight tolerances. If anyone's ever done edge wrap machines, you understand the challenges with this. But it's basically like, here's the plastic part. We don't have CAD for the vinyl or the foam or the foam-backed vinyl or cloth or whatever. So they give you the part and then the cloth. Then you measure the cloth and see how much crush it has. And then you kind of take a best guess. And you start offsetting the part and you design your edge wrap tool. So this is the edge wrap tool. And here's all the features used. Most of this is surfacing, right? So from here to here is pretty much surfacing, just to get all the contours and to manage everything that I'm trying to accomplish. Then after that, we start cleaning up, and these are the solid features, the base extrude, and then up to the surface, and then the trim, and then we put in the holes. And the very, very last thing that I do here is my wire burn cut that puts in my cuts so that my 5 pieces can come together. So all of these would touch in perfect reality except for the 10 or 15 thousandths wire burn slot. And I can buy a single block of steel and cut this much more efficiently in the CNC, wire burn it, and then put all my holes in. So then I just simply have a handful of body deletes that will manage each one of my individual parts, which are individually named, and I have an individual drawing for each one.
Why wouldn't you insert those bodies into the parts themselves?
Because that's an external reference. And at the end of the day, that particular thing doesn't give me a drawing any better or any different than this. The drawings actually get a little bit funky because inserting bodies doesn't always carry over your hole callouts and your threads and your dowels and all that kind of stuff. It loses some of that intelligence. So as long as we can natively manage the data from the drawing to the 3D model with the least amount of loops, the least amount of external references, and least amount of conversions, the better it is. So there's, I don't know, five drawings pointing to this one model looking at each individual configuration. And you can get, this. I see another hand. We're doing really good on time. I probably talked faster than I thought I did when I made the presentation. So more questions would help me look like I'm not running out of content.
Have you had a problem with configurations in drawings not showing up?
Nope.
Or where they don't transfer over even when you have several configurations?
Nope.
Have you seen the bug where it loses the external references?
Oh, all the time.
2018.
I haven't put a lot of time in 2018 because my customers haven't moved to it yet, and I'm not a suicidal guy.
Yeah.
So
I submitted the bug.
okay, good for you. Way to get that fixed for the rest of us.
It's not fixed yet.
Well, by the time I move to it, hopefully it will be.
I'm on the service pack 4 and it's still not fixed. I had to go up to corporate. So
They probably told you should have been using PDM.
they were able to do it.
Okay, that's good. And then, so the bottom nest is the same thing. It's just a little bit more simple because it's a single part file, or single configuration, I mean. So there's my simple surface offset, and then a handful of surface cleanup, my body, and then holes and a handful of fillets. And then my top plate is pretty self-explanatory. Any questions or comments?
Now, when you, in your other assemblies, you just put these individual configuration parts in that other assembly.
Yep, so if we look over here, I have this particular assembly has a PhD slide. We'll hide that panel. Yeah, so there's that, and this is that part with configuration 1. Now if I switch to master, right, this is all going to blow up, and you're going to see the entire, oh, it didn't blow up. I guess the mate references would have maintained. So it's just, yeah, I have 5 sub-assemblies, each with their respective part, and then the washers and the guardian and the bolts. This particular customer wants the hardware in there, so yay, McMaster. So on and so forth. Yes?
You're saying body delete, but you're actually doing the keep body, right?
It's the body delete command. I don't know what option I actually used. You're probably right. Yeah, so for every usable body that I need, I'm running a body delete command, choosing the keep option, picking the one body that I want, and then the rest of them go away.
Not suppressing 4 bodies or deleting 4 bodies.
Well, it's honestly the same number of features, right? If you had a feature that deleted each body or a feature that kept every body, it's the same number of features. The benefit here is that if more bodies get added, it's a little bit safer where it's going to blow them away versus having to add more features.
Yeah, I've seen that problem where somebody used the delete and then more bodies were added. Now that body's in every one of the other configurations,
Yep.
so they keep it safer.
Yes, I totally agree, and that is a good point. Not really what I was focused, not the point of my presentation, but that's an excellent point. The other thing is SOLIDWORKS originally added this because sometimes the one body you want to keep is in the sea of 1,000. And so they originally added it just from a clicking standpoint. And then we found out that it's a lot safer because, again, what's the one rule of CAD design?
It can break.
Stuff changes, and when stuff changes, what happens? Stuff breaks.
So you didn't externally reference the holes that go to the cylinder?
Not in this particular instance. The slide here is consistent enough that, how did I do that? Well, I know how I did it, but it's just a matter of the specific detail. So I think I designed it out once and then probably mirrored it over. Yeah. So I had to do an adapter plate here, so that was a throwaway, and that had to be mirrored over. But the convenient thing in this particular instance is I wouldn't have used an external reference because my slide is very stable, right? I knew the slide, I knew the profile, I knew this stuff. Within a statistical chance of never, the slide wasn't going to change. And so in this instance, because it was all a dedicated assembly and I only had to do one side and mirror it over, I just punched it out by hand, put in a couple dimensions. So yeah, I've got two dimensions, and these are natively in the middle. So this isn't dimensioned because it's just in the middle of a line that's midpointed.
So you have 4 instances of that hole there, and then you mirrored it over?
Yeah, then I mirrored the feature because it wasn't, it's a feature mirror.
Does your wall call out work in your drawings then?
Man, all these questions.
You asked for 'em.
Yeah, but we're talking about external references, people. Yeah, it's a good question. I don't know. We'll find out.
So you can't just right click and say open drawing.
No, because it's a configuration, and because SOLIDWORKS is looking for a drawing of the same name, it can't find 002-X. So my drawing is 002-1, 002-3, so on and so forth. So you are correct. That's not the one we're looking at, this one. So I don't know. If we delete that and re-add it, yep, there's 8. So I overwrote it to 4. Not F1 escape.
For more parametrics.
Yeah, and in this particular instance in the world of CNC, it was a price to pay. But you are correct. That is a undesirable result.
You could mirror the sketch.
It was on a 3D angle.
Oh, yeah.
It was on a 3D angle.
Yeah.
So if it was,
If you're using 18, you can mirror 3D sketch.
but it's not a 3D sketch. It's a 2D whole wizard.
Yeah, but can't you just mirror just a sketch?
Not in that way. All right. So, and here's an interesting thing. This is really heavy geometry and a lot of features and many configurations, so it's trying to rebuild through this. So my computer's going to lock up now for like the next, 30, 60 seconds rebuilding these configurations, which is mildly annoying, but at least the computer's doing the thinking, and I'm not spending like 15 minutes reconnecting external references, which is the whole point of this demo, right? While that's thinking, external references, finding and using. In any part file, you can, in SolidWorks, in the open dialog, clicking on any file, who knew that there was this reference button there? Now we're talking about external references in 3D design, but it also works with 2D drawings, right? A 2D drawing references something unless it's saved as a detached drawing. And the external reference does the same thing. Now there can be multiple. There's settings, we'll get to that. But it's going to tell you the assembly. And that is going to be this. So if you're opening up part 1, before you open it, you click on references, and it tells you referencing assembly 1. You know you're going to open assembly 1 to be able to resolve those references. And then once the part file is actually open, any file is actually open, you can do file find references, and it'll tell you what those references are and where it's looking. All right. Any other questions or comments so far? So show of hands, who's familiar with, has used, or understands virtual components? 3, 4, 5? All right. This is what virtual components are. This is my PhD slide, which has, I don't know, 6 parts. And it goes like so. So I have natively downloaded, I have 6 parts saved to my hard drive and 1 assembly file tying them all together. Virtual components embeds the part file in the assembly. So it's basically like a zip file, right? If I send you CAD data, I zip it up. Not only does it compress it in size, but then I send you 1 single file instead of 30 files. So this SolidWorks assembly, if I was to save it, it would save as if I save it off as a virtual example here, if I was to email you this file, you'd be able to open up this file with no parts because the parts are embedded inside of the assembly. And you know that by this little up caret. So, and And you also know it because if you open it up, it'll tell you copy of this body, this is a part file name, up caret virtual assembly. So it's embedded, it's saved inside of the assembly. Now if I try to make a drawing for this, it'll error out and say, you can't make a drawing, because what does a drawing have to have? Reference to a file. A file has to be on a hard drive. So because this file is embedded inside of an assembly, you can't make a drawing for it. Now in the instance of a purchase component, right, how many drawings do I need to really make? 0. So all of my purchase components, and I think I have the same thing on the Stego clamp. Really hilarious if I didn't. We'll find out. So all of my purchase components, I have a singular file on my hard drive, which is the assembly file. Every single other subfile, you can even do it with subassembly. So even the subassembly has that up caret symbol. So the subassembly and all of its components. Oh yeah, the Stego clamp's a better example. I should have pulled that up first. But you have all of those components in a singular file on your hard drive. That's the best use I've ever found for virtual components. I don't need to manage more data. And so how many of you have like your common purchase parts library, and you have folders, and you have the assembly and all the parts in that folder because you don't want it scattered about? Well, with this, you can get rid of all those folders because the assembly embeds all the files and it kind of takes care of your folder problem for you. The other thing that it does is when I download this Stego clamp, this pin in Stego clamp's world is the same pin as the pin used in a different size. Well, now I have a file conflict because I have the same physical file in a different folder on my server or on my PDM or whatever it might be. If I virtualize everything, the only file in my PDM or on my server is this assembly file. Every single one of these subfiles can be the identical name as the other Stego clamp that's one size smaller or one size bigger, and I have 0 conflicts.
Could you also do that with customer parts?
It is possible. I don't.
Customer data?
You could. The risk with that is customer parts tend to change, and then you have to unvirtualize it, open up the new step file from the customer, add it in and re-virtualize it, and that would get really weird. Come on, your customer sends you updated geometry all the time. Right. That gets really weird. The reason it's such a good fit for purchase commodities is because they never change, right? The Stego clamp simply cannot change the geometry, or at least the critical geometry of this clamp. Otherwise, they can never sell a replacement part. So when you download a purchase component, you're absolutely guaranteed that that geometry, that part number, as long as they keep selling, sometimes they obsolete it and say, here's a new thing. But as long as they keep selling that model or a similar model, you know the geometry is going to be stable. And then that way you can just virtualize it and run it for life. I wouldn't virtualize stuff when there's a subject to change. That's kind of playing with fire.
Can you step through the process of downloading or taking
Sure.
it?
What should we download, folks?
SMC or whatever.
Hey, look, it looks like I got the login for PhD. We'll do that. Hey, look, we'll just open up something I've already downloaded. That'll be fun. Nope, not what I wanted. Submit CAD request, maybe? There it goes. So we'll let that generate. Yeah, no problem. We'll run through that. Go back to my presentation to see how behind I am. All right. So more using or finding and using continued. If you see this little caret symbol in your feature tree, that means that feature or a sub-consumed feature, right? In this instance, it's the sketch of the whole wizard, not the whole wizard itself, is externally referenced. So if you right-click on that, you can list external references. It'll show you the dialog. Break all just totally abolishes the reference, never to be resolved again. Lock just says whatever it is right now, we'll lock it, and we'll never change it unless you unlock it and rebuild. External reference options. If you've gotten different results on different computers, or new computer to old computer, or your coworker or whatever, this might answer some of that. When you're editing the component, the button is depressed here, and the command manager switches. The no external references button, if you try to make it, you can click that, it'll be depressed, it looks like that. And if you try to make a reference, this error might show up. If you click don't show me this again, it just won't show up again. And then you can't figure out why it doesn't work. That's probably that option. And there's also system options that will default that on. So there's a system option that says when you go to edit a component, it'll automatically toggle the no external references, and you have to manually untoggle it versus have it automatically untoggled to manual toggle. So there are system references that kind of screw up your workflow there if you're not expecting that. Then there's another system option that allows multiple contexts for parts. So that example would be, back to my diagram. So if this was a real thing, and if I really did this, part number 1 has 3 contexts to part number 7 through 3 different assemblies. There's an option in SOLIDWORKS that locks you to 1. If you have one reference here to here to here, and you try to make a second reference here to here to here, it'll just error out and say no. Now, the really screwy thing on SOLIDWORKS' side is if my setting says yes, and I create 2 references, and I send CAD to Robert, and Robert's setting is no, SOLIDWORKS is like, I'm told I can't do this, but it happened. So yeah, I've had a couple tech support phone calls on that. That's really exciting. Moving on. So external reference tips and tricks. Oh, I think my download's done. Who wants tips and tricks or who wants download?
Yes.
Perfect. Download first. So here's my SOLIDWORKS file. We'll just grab this. I have no idea what this is, but I was expecting more parts. So we'll just dump it there on the desktop. Aha! So right now, if we go look at my desktop, I remember what this is now. If we look at my desktop, among all my messy folders and stuff, I see there's 2 files here. If I just right-click on these 2 and select them and right-click and say Make Virtual, shows me an error, yes, I want to make virtual. It breaks the relationship to the files on the desktop. If I go to my desktop now, who thinks the delete key will work? Oh, it worked. So on my desktop, I only have this singular SOLIDWORKS assembly. The files are, the parts are gone. If I click Save, and now this is CAD I can provide. So I'll upload this CAD with my presentation. You can all download one SOLIDWORKS assembly, and it'll have 2 parts in it. Super cool. Yeah, so I've just now got this one SOLIDWORKS assembly, and it has these 2 parts embedded inside of it. And they're still real parts. You can still open them. You can still modify them. You can still mate them. You can still constrain them. You can still do anything you want. They're as real as any other part. They're just not on the hard drive. Sir?
So then delete all single part files from your library?
Yeah.
You have just an assembly.
Yep. I just did that here on my desktop. I think I was at some customer a while ago and showed them that, and they went through a massive deleting spree. It was pretty awesome. All right. What was the next thing? Oh, tips and tricks. So the first tip and trick is avoid using external references. The second one is wireframe is your friend. How many of you are really familiar with the right-click, select other, right-click, 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 left-click to get something? I was at a customer once and they had 30 holes that were just in odd patterns because they're bolting something that connected to a customer part, so there's no rhyme or reason. And so they were right-clicking, select other, right-clicking, left-clicking 30 times to connect those holes. Well, you can just switch to wireframe and pick anything you want. Wireframe is awesome. Now, I hate wireframe. It's the only thing I ever use wireframe for. But let's pretend for a minute that this part doesn't have those holes. Oh, this will be a great example because we're going to cover all kinds of stuff here. Find the other one. Okay, so this is going to be multiple tips and tricks in one. First of all, what assembly am I editing? The lowest possible level. If there's one thing you learned tonight, that should be that. Okay, so I'm editing the part inside the assembly at the lowest possible level, and I need a bolt hole pattern for these 2 Destaco clamps. So I'm going to launch my hole wizard. I don't know what size this is, so we're just going to say it's 1/4-20, because that sounds exciting. It's like my favorite hole ever. And I'm going to click here, going to click there, going to click there. That hole looks really small. Let's bump that up. 3/16/18. 3/8/16 looks better. All right, why did I only put 3 holes in there? Because the rest of it is geometric. So now I open the part file, edit that whole wizard sketch, draw construction lines, and I can very easily drop in the rest of my holes. How many external references do I have for this whole pattern in that assembly? 3. And then, because every good designer puts the origin center mass, who's heard me say that before? I can mirror that pattern over, jump back to my assembly, every hole that I need for both clamps, because I have an origin in the middle, 3 holes, external referenced, logical orthographic pattern, mirror those points to the other side.
You could have done that with 2 there.
I'm sorry, what?
You got 1 more than you need. You could do it with 2.
I could have, you're right. See, there's always room for optimization. So this was pretty easy because I had through holes on the Destaco clamp, right? We all recognize that. These dowel holes, and this whole thing had to be adjusted, so their dowel holes are slotted in the fixture and they're pressed into the plate, and then my counterbore holes are slotted here. But my dowel holes are a little bit more difficult. We'll use the counterbore holes. We'll pretend we don't have counterbore holes. I appreciate Radar and Todd there keeping me honest with how many actual references I needed. It's always a good audience. So we'll get rid of these bolts because obviously I wouldn't have bolts at this point. So I'm going to edit this part. Launch my hole wizard. We'll ignore the slots for now. Don't know what size this is. We'll pretend 5/16/18 and it's a socket head cap screw. Through all positions. This is what I see all the time. Click, right click, select other, select other, select other. Grab that edge somehow. Hold down control, pick that point, make concentric. Who's done this? Who's seen this? Who thinks there has to be a better way? Wireframe. And you hover and click. And this one's going to be difficult, but hover and click. And then now obviously I could mirror. I didn't really need the third one for everybody that was really wondering, but I was showing the wireframe feature. Cut me a break.
Usually just want to hit the body.
Hiding the body does also work. Yep. The hard thing is then to go back and find it, right? But there's that. Make that midpoint, box select, mirror, and you've got a whole pattern, 2 external references, super fast, super easy. I'm really just showing my part, but anyway, sir.
Question, superficial, but do you leave your mirror lines undefined in the length?
Yep, so I used to define the length of them until SOLIDWORKS got smart and didn't undefine the sketch because of one construction line that didn't have 1 point. So prior, I think it was 2014-15, if you had a point that was undefined, there was a minus sign in the sketch here, which said that, right? Like when I grade homework, if there's a minus sign, people get points off. I don't even open the sketch, right? Like minus sign, you got less points. Since SOLIDWORKS got smart and figured out that, oh, there's a lot of legitimacy to having a construction line that isn't defined fully. However, I think if it's both ends, it then gives you a minus sign. Nope. So a construction line doesn't make the sketch underdefined as long as it's defined in its body, not in its points.
What if it's not a construction line?
Then it will error on you. Yep. So if I do something like this, now it'll be minus. That I'll go hunt down and fix till my dying day. I'll give points off and I'll tell everybody they're doing it wrong. But as long as there's not a minus sign in that sketch, then I'm pretty happy. So what I used to do, I didn't like dimensions, so I'd either make it coincident to something, or I'd make it equal to something, or I'd just put something on there. But I don't bother anymore. I'm sorry?
Why not make it infinite length?
Because that really bugs me.
Really?
Yeah. Because it's geometrically infinite length. I mean, that's how the engine resolves it. So I don't need the line to go infinitely, because usually it goes through something else I'm trying to see. It's just more stuff on the screen that I don't want. There's nothing wrong with that, right? I'm not saying that's a bad habit. It's just I don't like it.
that side, they always stayed within the plan. So.
Yeah. Pro-E does a lot of things that we don't really support. So wireframe is your friend. Use as few as practical. Mirror, use orthographics, whatever. Verify the external reference lowest level. Understand how your part's going to change. And when sketching, establish the necessary external references and then finish it as little as possible. Working inside the assembly as little as possible. Woohoo, I'm done. And 4 minutes to spare. Questions?
I have a comment, Andrew.
Yes, sir.
Your virtual parts
Yep.
work really well in EPDM or SOLIDWORKS
Yep.
EPDM.
Yep.
When you don't want to have to create data
Yes.
for every single part.
So I was at a customer once. Todd has an excellent point, and this will just drive it home. I was at a customer once, and they opened up a position. They hired a data input guy because they were using, it wasn't SOLIDWORKS electrical, but some electrical package in conjunction with the mechanical. So their electrical package was generating circuit boards with all the resistors and capacitors and relays and CPUs and everything. And then mechanically, it was generating a 3D part file for every single component, like it should. And then they kicked that over to the mechanical side, which is all totally blank properties. They hired a guy to type in properties for every single component because their PDM rules were the properties couldn't be blank. And it was a big enough company that they couldn't get IT or their SOLIDWORKS admins to make any exception. So somebody conveniently mentioned to them that virtual parts exist, and they could just like lie to PDM and say that those parts don't exist. They don't have to do any data cards. And I think that kid probably looked for another job after that. But long story short, right? Todd is correct. If you have those type of rules, it's still a legitimate part, but because it's not creating a physical file, one of the downsides is you can't make a drawing, but one of the upsides is you don't have to manage the data, and your data management, your PDM systems are blind to the fact that those parts exist from a physical file standpoint. Yes?
Do you know if that, you know what Tom task?
The test scheduler, yeah?
Yeah, Tom task, can you automate making virtual parts through that?
I don't think so. I mean, I'm sure you could with custom code. Absolutely. With custom code, you can do whatever you want. But I don't think there's any native functionality to do that. Any other questions or comments?
The other comment was Radar asked about using virtual parts for CAD data. Inside SOLIDWORKS PDM, it can be a good idea because of data cards again.
Yeah, it would depend on how the customer gives you the part. I would probably say that if they gave you an assembly that had thousands of parts, it would probably be best to save it off as like a part file and just have multi-bodies. Unless you needed the kinematic motion. But yeah, there's certainly that. My biggest thing is virtual parts really do a very, very hard, rigid break of the reference. So if you ever get new data from your customer, it's often very hard to patch that up. And any like offsets you did from CAD geometry or any surfacing you did, that's all going to break. That was SOLIDWORKS' goal with the new 3D interconnect, is you don't even have to convert and save the CAD. You can just leave the native file on your hard drive, and then they update it in CATIA. They send you new CATIA files. You overwrite the native hard drive. All of your surfaces, all your references, all your surface offsets, all your surfacing update in theory, and it's a lot less work. I've had mixed results with that. Depends on the sweeping aspect of their change. But it is a lot, it's a step in the right direction, we'll put it that way. Any other questions or comments? All right. Again, I'm Andrew Sky from SmoothLogix. I think we got some literature back there. I'll find business cards in my backpack here. If anybody wants to contact me for any reason, more than happy to help. I would expect in the next week or so the presentation and any source files I'm able to give will be up on YouTube. Thank you very much.